Okay, so just to kind of make you aware, so this light suggests that this lecture is being recorded, so if you kind of like shout out something racist or inappropriate, that will be recorded. So, yeah, okay, you've been kind of forewarned. And also just point out this is a new thing that we're doing this year, so for next year when you will kind of be students, hopefully at Edinburgh, all lectures will be recorded. And this is not so you can kind of just rock up late or stay in bed. It's useful as a revision tool. It's also very useful for if lecturers speak very quickly, like I tend to, you can listen back slowly. So it's a thing that we've been doing in response to student feedback. So students want it, so we do it. Yeah, so hopefully all this will be recorded. And if you have a question, I will throw this at you. And this is a microphone that will pick stuff up. So not to discourage question answering, it's quite kind of soft. So don't be afraid of the microphone. Right, we'll just wait for a few more minutes in case people want to squeeze their way in. So we've just got some of the photos from some of the field trips that our earth science students do as part of their courses, just rolling through on a slideshow. So if you see something you like, yeah, come to Edinburgh and go to these places that are not in Edinburgh. We also do field trips within Edinburgh. We have our own volcano in the middle of town, so it would be stupid of us not to go to that. If you have any questions that you don't think up right now, my email address is earth.sciences@ed.actorg. I should say that I'm Alex Thomas. Hi, everybody. So I also have hurt my shoulder mountain biking, so if I don't point as much, then it's because I've done that. Yeah, so earth.sciences, that gets eventually to me. And if you have queries about the content of courses or the admissions process or what combination of subjects you're currently doing, then that's kind of, that's for you. So, yeah. Okay, so I think we'll start the whole event here. So hopefully this should take us to get to the first slide. So the purpose of this presentation is, I guess, kind of twofold, really. So some of you won't know much at all about earth sciences. Okay, so part of this talk will hopefully tell you a little bit more about what the subject is. But hopefully some of you might also already know something about earth sciences, either through stuff you've seen on the telly, what your ideas of what geology or maybe environmental science or geophysics are. And the part of this talk will be what is it like to do those subjects at Edinburgh, a bit of the course structure, and kind of the things that we do across the wider university to make the student experience nice. And hopefully convince you to come here. So this is a picture of a lecture theatre, much like the one you're in today. There's a white guy with a beard at the front, so this is a common feature, many of Edinburgh lectures. But the reason I have this slide up there is that if you look around the room, and if you look around the room on the slide there, you can see that there's maybe some plastic flooring, some metal in the benches. Everything in that room and everything in this room is made out of something that a geologist has dug out of the ground. Even the things that are made out of wood, the benches and kind of maybe some of the structural beams in the building, those things that were growing needed nutrients, needed some key elements that are essential for life, and those elements ultimately come from the earth. Okay, so understanding these element cycling of nitrates and phosphates and pollutants between the earth, the solid earth, and also the bit of the earth that we use, the crust and the atmosphere and the oceans, is really important for basically the sustainability of our entire society. So geology isn't just about kind of resources, oil and gas, energy, all those things, but a large part of it is, and that will continue to become relevant as we move to a fossil fuel-free kind of global economy. We will always need stuff out of the ground, and we will also always need to put it back in the ground once we've finished with it in a kind of a safe, kind of non-damaging way. And that's becoming more and more important part of our courses, but also part of our students' kind of destinations as, I guess, employees of the global kind of society. the first part of the talk, what is earth sciences? So it's a science, so we're using the sciences of physics, chemistry, biology, mathematics. We're using these scientific tools to observe the Earth. And we can observe that Earth in that Earth, this Earth, I guess mostly this Earth, but we also look at other planets as well. We can observe the planet in many different ways. So that can be either via satellite, looking down at just the visual spectrum. We could be looking at maybe a map of the gravity. Ow, that really hurts. Map of the gravity of Earth. We could be looking at kind of false color images. The one that's got the ocean on here, that's looking at the greenness of the ocean. So that's a measure of the chlorophyll. So we can use physical tools, remote sensing, or physics like gravity or electromagnetism, to look at the Earth, to understand it. But we can also use our same understanding of science to try and model how the Earth works. Okay, so an example of that is modeling of the Earth's interior, which we can't directly observe. So we combine some of our physical observations using seismology, gravity, electromagnetism, with physical models that we make in a computer that we try and match up to those observations. So it's very much a physical science, but one that is based around observations of the Earth. So if you like science, and you like being outside looking at stuff, then it's for you. I guess I mentioned a couple of minutes ago, we're transitioning to this kind of fossil fuel-free world, hopefully. And this is one of the reasons for that. So this is actually last year's global climate difference between pre-industrial and now. So this is basically how much warmer the planet is. I mean, one of the things earth scientists do is basically come up with these kind of maps. We go out and make observations. We try and model these differences to understand how the global climate is responding to these, the forcings of CO2 in the atmosphere. So there are a number of things to think about here, some of the science questions that we as earth scientists are interested in. One of them is, it's not just getting warmer everywhere by the same amount. There's a lot of regional differences in this. Okay? So understanding those regional differences, how will those regional differences change in the future? That's one important thing. But then also the solution to this problem, and this really is a really massive problem, the solution to this problem is going to involve earth scientists. Okay, so it's our fault for digging out of the ground and burning it. But the solutions to this problem are going to involve putting it back in the ground. So things like carbon capture and storage, not as a kind of let's make coal slightly more attractive, but also just actually taking carbon dioxide out of the atmosphere, okay, paying someone to do that. You have to put it somewhere. And the only sensible place to put that is in the ground. This is an earth sciences problem. Okay, so this is going to be a large area of growth in the future. So I like to think of how, I guess, why one would want to do earth sciences into these three main categories. We're interested in just how the Earth works. Okay, why do we get mountains in some places and not others? Why are the Himalayas so high, whereas other mountain ranges are not? Why do we have kind of seamounts in the middle of ocean basins? Just what is it? How does this thing work? Just from a purely scientific curiosity. There's the thing I don't understand. I want to understand that thing. We're also motivated to do earth sciences because the things that the Earth does, right, it kills people. Right? We just had an earthquake in Mexico. One of my fifth-year research students is currently out there trying to help help the kind of the rescue effort there. But understanding natural hazards, whether it be earthquakes, volcanoes, tsunamis, meteorite impacts, all this kind of this crazy stuff that the planet can do, or the natural system can do to us, there's a need for that to happen, right? Because that costs both money, but also costs people's lives. So that's important. And the other bit is this resources and energy. So that used to be, we're going to train our graduates going off and do oil and gas research and make loads and loads of money. Less so about that now, but it is more diverse in the kinds of energy kind of sectors that our students go into, be it wind, be it kind of hydro schemes, be it kind of dealing with radioactive waste, which kind of brings up this extra little bubble, kind of this use of resources is becoming less about just getting them out of the ground, selling them, to actually doing it in a responsible way. and understanding how we can do it responsibly and how we can monitor that it's being done responsibly is part of the earth sciences. So if you care about any of those things, you're in the right lecture theatre. Okay, so I'm going to do a little bit now about why you might want to come to Edinburgh to study earth sciences. And it's a fantastic city, and there's a nice shiny picture from our kind of stock images of when it's sunny. It's always sunny in Edinburgh. It's really not. So one of the reasons to come to Edinburgh is that it is situated in such a fantastically interesting geological locality. Okay, there's Edinburgh Castle, there's the volcano that it's sitting on. So it's really, really nice to be able to be in a city where all of these kind of the things that we're studying are very accessible. Okay, I mean that's not unique to Edinburgh, but Edinburgh has a couple of volcanoes in town, has some really fantastic localities around the coastline around here that we go and look at. So this is a map of Scotland, and all of the different colours on this map are what we would call different geological terrains. So they're basically different types of geological environments. So the Northwest Highlands is basically the inside of a fossil mountain belt. So it's basically like going to the Alps, but instead of looking at the rocks on the surface, we can climb inside the mountain and see how it works from the inside. We've got volcanoes on Mull and Ardnamurchan, which are the kind of volcanoes that you can't really, we haven't really observed going off in kind of modern or historical times, because they are colossal volcanoes. They are huge. If a volcano like that erupted, it would be it would change the global economy in some substantial ways. Okay? So one of the great things here is, again, we can climb inside these eroded old volcanoes and we can look at how they work. There are different sedimentary regimes over the whole of Scotland. We've got the Midland Valley, which is kind of a nice analogy of the North Sea. It's basically very, very geologically diverse. Okay, so this provides opportunities to go and see lots of different kinds of geology as we kind of do our field trips. And I think these are going to appear very slowly. Okay, so these are some of the localities where we actually take our undergraduates on our degrees. And you can see that we go all over Scotland, because Scotland is literally the best place to do geology in the world. It just is. It's fantastic. We also go to places that are not in Scotland, because some of these processes that I was talking about, so these massive volcanoes, the active tectonics, you can't observe in Scotland because they're no longer actively going on. So we do go to some places where we can actually see an active volcano and go, well, let's not go too close. Or we can see where the crust is actively tectonically deforming, regions with lots of earthquakes, and we can actually see how that's affecting how sediments are being deposited in sedimentary basins, kind of in the live place. We go to Jamaica as part of the environmental geoscience course because we want to study a tropical environment, which, I mean, Scotland is nice, but it's not that nice. Yeah, so we also go some field trips in England as well, if just for equality and diversity, I guess. Just to point out, that, so this is where our courses are taught all over Edinburgh. So we're at King's Buildings down here in the science campus. In the first 2 years, some of your courses and maybe some of your option courses later on in the year will be in the central area. Okay, and let's see if I can use the pointer. Control click. Okay, you can all see the pointer. So this is Pollock Hall. So this is the student residence where you'll be mostly living in the first year. To go from here to here, I did it in 8.5 minutes on my bike on Thursday. So it's not that far. There's a free bus that goes up and down. So it's actually quite a compact city, easy to get round. There's a nice volcano in the middle of it. As long as you don't cycle over the volcanoes, it's actually surprisingly flat. Right. Another reason why Edinburgh is such a good place to come, and actually if you go to the Grant Institute, one of our buildings on site, we're having an open day for kind of mostly for kids, and you can kind of like pretend to be one of these old guys and have your picture taken in a setting with lots of kind of like fancy stuff. But Edinburgh is the place where modern earth sciences was developed as a subject. So it's quite nice to be able to kind of teach these kind of things at the localities where the science was first figured out. So this picture here is a place quite close to Edinburgh, just on the coast south of here, a place called Sicker Point. So it's one of the places where people first figured out that the age of the Earth was much, much, much older than the 6,000 years or so the Bible says it is. So we have rocks that are deposited and then tilted vertically, and the observation that this guy James Hutton made was that the rocks on top of those are deposited at a different angle. So there must have been some long period of time where those rocks were deformed and tilted. So it's really nice to be able to teach these kind of things in the place that they were first done. But the reason I'm showing this slide is, not these really old, famous, dead white guys. It's quite nice, but the reason I'm showing it is that actually, so one of the guys on here, John Playfair, in the middle, was not really a scientist. Okay, so he was just a really rich guy that was quite interested in science. And all of these other scientists, they were making these groundbreaking discoveries and interpretations of how the Earth works. But being scientists, they wrote the dullest books you could possibly imagine. They are really, it's really hard work to get through these things, right? And the really important thing that John Playfair did was, other than being kind of really rich and inviting lots of rich and kind of important people during the Scottish Enlightenment to come and listen to these guys talk, he wrote popular science books. Okay, so he was able to communicate these scientific ideas to the wider public. And this is a really crucial element of what science is. Okay, so I guess one kind of reasonably famous quote is that science isn't finished until you've communicated it. And this is a really important part of what we try and do during our degrees. So we have a course in the fourth year, an option on geoscience outreach, where we kind of get our students to come up with some part of science that they're interested in and communicate it to the public in a way that they want to do. That can be kind of schools outreach, it can be working with an organisation like the National Trust to make poster boards for kind of their kind of like geo walks or something like that, making videos. It's a really nice course, but we also try and embed this skill of scientific communication throughout the whole degree. It's a really important skill set that we try and get our undergraduates to do. So that's why I show that slide. We also have a bunch of active world-leading researchers. So I guess Gabby here just made a Fellow of the Royal Society. And it's, to a certain extent, as an undergraduate, teaching is important. Research, less so. But actually, all of our researchers, all of our kind of top, world-leading researchers, they are fundamentally engaged in the process of teaching. You cannot get a job as a lecturer or a professor, no matter how good you are, if you're not committed to teaching. It is impossible. The university said, no, we're not having those people anymore. So it's also important from a teaching perspective, because when you get on to some of these higher level option courses in the fourth, fifth year, maybe you're doing a research dissertation on something, it's useful to have people that have got a very broad range of skills. Okay, so because Edinburgh is a very large department, we have a huge range of expertise at global leading kind of level. So when it comes to your fourth year, you're able to do the science that you want to do. You don't have to fit into quite a narrow kind of range of stuff that your department is able to do, because we're huge, very big. We're also quite good. If anybody is choosing a university based on a league table position, good luck to you. It doesn't really mean it. Every university has its own version of how it looks at league tables. Here is how Edinburgh looks at the REF, which measures research. Obviously, we choose a metric that makes us top. You can come up with a different metric that makes us look less top. What this basically says is we are very big, and we are very kind of like good at being kind of very broad across a wide range of subjects. Say Oxford, very small department. Okay, so they have a smaller score in research power, which is goodness times amount. The Guardian league table, it measures teaching. It goes up and down every year. I really wouldn't pay too much attention to them. We perform quite well, but the universities that fall at the bottom of them, they're not bad universities. Right? I think Guardian, Aberdeen came really badly. It's not to say Aberdeen is a bad place to go. They have these hilariously pointless metrics like entry score. That doesn't measure how good your university is. It says how good the students are when they arrive. Anyway. So we're going to have a little bit of a detail now into the individual degrees. So the degrees that we do geology of physical geography, we do environmental geoscience, and then a range of geophysics degrees as well. I should point out that we also do a geography degree and a geography BSc degree. So that might be something that you're interested in doing. If you are, come and chat to us at the stall. But because we have this kind of wide range of stuff, I like to kind of think of it as actually, I guess it's not a Venn diagram, it's an Euler diagram, but this kind of overlapping thing that these degrees aren't really very separate. There's a huge amount of overlap between degrees. So if you end up doing a geology degree, you won't just be doing geology, you'll be doing some geophysics, some environmental sciences, maybe a bit of geography in there as well. There's a huge amount of overlap between these things. And also, it's very easy to switch between degree programs as well. So geology is all about understanding the solid Earth, okay, from the core to the, I guess, also to the atmosphere we're interested in, but basically we're interested in the physical processes of the Earth. So we're interested in volcanoes, how they work from the inside, also how they impact the environment. There's a little bit more focused on natural resources in this degree. But it's interested in the solid part of the Earth. It's what you might traditionally have seen kind of, the public science programs that Ian Stewart does of geology. I mean, these are kind of some of the words that you get when you take our geology degree and kind of make it into a Wordle. If you're interested in rocks and how we can make observations of rocks and interpret how that thing has formed over time, what processes have affected that, what conditions has it been under, that is the kind of the thing that's for you. Environmental geoscience is a degree that is often poorly understood. It starts out being very much like a geology degree. And that's because the environmental geoscience degree is a degree that is interested in the interface between the solid Earth and the things that live on Earth. So life. All kinds of life, from bacteria to people. Okay, not that people are at the end of a spectrum that is better than bacteria. Bacteria are just as good and sometimes more interesting. But it's interested in that interface. So we're interested, first of all, I guess there's quite a lot of chemistry involved, because if you want to understand how the Earth, solid Earth, affects life, that's effectively a series of chemical reactions. So it's got quite a lot of chemistry in it. I kind of like to think of it as, if we want to think of the Earth as a beaker, and we want to understand the things that are going on in that beaker, we also need to understand what the beaker is made of. Okay? And the beaker is made of the solid Earth. So it has a bit of geology, but it also then goes into more environmental kind of questions, such as, how has climate changed through the past, but also questions about how will a change in the acidity of rainfall affect the pollutants that are leaching out of this soil, which is sitting on an old mine. Okay, so it has links to basically resource management, making sure things are nice and safe. We're also interested in things like problems to do with climate change, like sea level rise, changes in weather patterns, the monsoon, things like that, changing kind of the habitability of the planet, effectively. And yeah, these are the kind of Wordle things that brings up. So we're basically interested in the environmental part of geology. Geology and physical geography, I don't think this really needs much explanation. If you understand what geology is, most of you have been exposed to physical geography in school. So this is a course that's really interested in those surface processes, things like erosion, landslides, volcanoes, glaciology, things that physical, chemical, biological processes that happen on the Earth's surface, and how those impact kind of the use of that part of the Earth for resources, for living on, for agriculture, those kind of questions. So this is some of our students looking at a fjord in Iceland on one of the fancy field trips that we tend to go on. And yeah, I guess you will be familiar with the terms that geography is involved in. That's kind of, those are up there. So geophysics is very similar in its motivations to geology. We really want to understand how the Earth works. We might want to understand how it's changed through time. Okay? But geophysics takes a much more physical approach, as you would expect from the name. It's almost identical in the first year to a physics degree. Okay? So we're looking at using tools of physics to understand how the Earth works from the inside to, effectively, to the tops of clouds and space. Okay, so we're understanding. So that, I guess one of the things that people, I guess, don't realize so much that things like weather forecasting requires an enormous amount of physical knowledge about how fluids rotate on how fluids move on a rotating sphere. And there's a bunch of demonstrations outside in the physics department of people with like tornadoes whizzing around in a bottle. You can actually come and see them in the Grant Institute as well. So it's basically applying physics to these problems of observation and modeling of how the Earth works. And there's another Wordle that you probably are not going to have time to read, but it's, yeah, things like weather, also climate change. So some of our climate change researchers that were involved in writing the IPCC kind of fifth assessment report, they are part of our geophysics teaching team. Okay, so Gabby, one of the scientists I showed earlier, so that's what she does, and that forms part of the geophysics degrees. So the overall structure of what we kind of are doing here is we have degrees that have a pre-honours, which is a first year and a second year. There is also possible to enter directly into the second year if you have sufficient qualifications at entry in terms of advanced hires and good subjects and grades A-level. But this is basically just to give you a fundamental grounding in the subject. So there's a lot of introductory courses in this. It also allows you to take a lot of options, and we'll come on to that in a bit. Moving on into the honours part of the degree, so years 3, 4 and 5, so some of our degree programs have an integrated master's option, if you want to do that. And in our degree structure, that's the part that counts. So none of the stuff you do in the first 2 years actually counts for your degree, you've just got to pass it. Okay? It does, I mean, the grades do count for some things, like they will appear on your transcript, they will maybe determine if you're eligible to go on a year abroad, things like that. So it's worth trying in the first 2 years, but it doesn't count for your degree classification at the end. And depending on what degree you're doing, the third year is usually quite focused. So we don't give you many options. And the reason for that is we're making sure that you're prepared for what comes in the fourth year, so you can do our higher level courses in the fourth year and also do your research dissertation. So the introduction to the research dissertation starts out really in the third year, making sure that you have the necessary skills and knowledge to be able to do that. And then into the fourth year and then into the fifth year, we kind of open up the degrees a little bit more, and you're able to take more options in subjects that you're more interested in. So if you're more interested in paleontology, kind of how dinosaurs kind of did their thing and became super popular and then not so popular, then you can take courses in that. But if you're actually interested in reservoir engineering, if you're interested in resource management, that kind of thing, or marine systems, then there are courses in those that you can kind of then go into. So to go down into a little bit more detail now, so the 3 degrees in earth sciences, geology, physical geography, and environmental geoscience, so these are very similar. So I've made them all on one plot. Geophysics is slightly different. So in the first year, you'll do a bunch of core courses, and depending on how much maths you've got on entry, we'll get you to do a maths course, and then you have some options to do whatever you want, literally whatever you want. You can do any course you want to in the university, as long as it matches your timetable, and it's not medicine or veterinary science. Okay? And then in the second year, you start to focus down on the degree you're interested in. So I guess you point out what the courses are. That would be sensible, wouldn't it? Yeah. So ED. So Edinburgh really loves acronyms. When I started here, it was so frustrating. So we do Earth Dynamics, which is obviously ED, which is our introduction to the Earth system. How do rocks form? How does plate tectonics work? That kind of thing. How do rocks melt? That kind of thing. How do volcanoes work from the inside? Then we have a course called Introduction to the Geological Record, which is all about how we make observations of these things, how we observe rocks in hand specimen, under microscopes, and also in the field. This has a field trip that goes to the Lake District. Evolution of the Living Earth is all about how the Earth formed and became habitable and changed its habitability through time. So it's got a little bit of paleontology in terms of looking at the fossil record for evidence of this evolutionary process over time. It's got a bit of chemistry to basically provide some introductory chemistry, but also to start to introduce this concept that there's this interaction between the solid Earth providing these key nutrients which are essential for life and how that has developed through time. Moving into the second year, there's one core course that everyone does which is called Geomaterials, which is again looking really at the physical and chemical properties of the stuff that the Earth is made of. So if you go into the Sanderson building and have a look at our information stand, you'll be able to look down the microscope and see some of these minerals that rocks are made of and some of the observations that we can make of them. Then the geology program becomes more geological with a course on global tectonics and the rock cycle, which is about tectonics and the rock cycle and how, and really importantly, how those two are related. So not just, this is sandstone, it forms by bits of like sand becoming a stone. It's how that is related to the geological and tectonic environment. So to form a sandstone, you've got to make a hole in the ground to put the sand into. How do you do that? How do you get a hole suddenly in the ground? What kind of tectonic environment do you need for that to happen? We introduced geophysics in that course as well. And then environmental geoscience. We have a course in oceanography and environmental geochemistry of the Earth's surface. And then physical geography, a course in geomorphology. How do we interpret from the landscape, shapes of the land, what processes are currently going on, what processes have gone in the past, which is important for understanding the hazards in that region, but also for understanding the physical processes that have gone on in that environment. And then again, we have some options where you can do what you want. You can take some of these core courses from other degrees. So if you maybe want to do a switcheroo and you thought, definitely want to do geology, and then you turn up, do some geology, and you go, actually, want to do environmental geoscience. If you'd have made those some of your options, then it's possible to do that switcheroo, okay, depending on if there's enough space in the course and you've passed all of your other courses. Geophysics, many fewer options. And that's because the first year, you're effectively doing a physics degree. Doing a physics degree, you do physics, maths and physics, and more maths and physics. And then you take some of our introductory courses into kind of in geology. And then again, in the second year, we start to split off into these different flavors of geophysics. So if you want to become more of a meteorologist or more of a geology geophysicist, you'll take courses more appropriate to that stream that you want to go into. And again, if you take options, you can do switcheroos there if you want to. Looking into the more detail of the third year, you can see here that we've got in each degree program, geology, physical geography, environmental geoscience, geophysics. We've got some core courses, and those are the ones in white here, that really provide the critical information that makes you a geologist or makes you an environmental geoscientist. One of them, environmental geoscience, geochemistry and data analysis. So that's a course that I think that's, have I made that the next slide? No, I haven't. That's annoying. Oh well. So that's a course that I teach, where we provide a bit of theory. So people come into a lecture theatre like this, and we tell them some theorems, about how we can use chemistry to tell us about Earth processes. So we might look at some of the isotopes of strontium and how we can measure with a mass spectrometer, and we go and maybe have a look at the mass spectrometer we've got in the department, and see how that can tell us about how the balance between erosion and weathering and volcanism has changed through geological history. But that course isn't just about learning about how we use geochemistry. It also incorporates a bit of programming, so we get students to do some programming, learn how to use Python, and we do that in the context of geochemistry through the data sets we use as examples. So we're providing skills and knowledge through the same course as we kind of go along. We try and kind of integrate it all together. That course also has a bunch of lab work to kind of add some lab training, so we get to use some of the facilities that we have in the School of Geosciences, which is another reason why Edinburgh is quite good, because we actually allow our students to use these big shiny bits of kit, which cost millions of pounds, to make some measurements and get some data and understand that data doesn't just magically appear out of the air. I will measure the chemistry of this rock, and I have the chemistry composition of this rock in this table. It's not that simple. And going through that process allows our students to really understand the things that can go wrong. Okay, some of the unknowns of kind of data analysis in terms of what could be wrong with these data sets. The final year, all degree programs have some big research dissertation. In the geology degree program, that's a geological mapping project where students go out into the world, wherever they want to, as long as it's safe. We do check it's safe. We don't send them off to Syria or somewhere ridiculous. But if Syria wasn't at war, we'd allow our students to go to Syria. If they wanted to go and map Syria, that would have been fine. They do that. Other degree programs have different kinds of research projects which are not necessarily as field-based, but could have some field sampling. So one of my students is off to sample some rivers in the Highlands for their copper contents, to look at contamination of those rivers. And that can either be field, lab, computer-based. It could use remote sensing of glaciers, perhaps. It can use a whole different range of kind of scientific investigations that our department is currently doing. And then we have fewer core courses that kind of define what the degree is. So you can see what they are there, and that some of those have got field trips associated with them. And then again, we open up, so we have these many courses that people can take if they so wish to. I guess so. We've gone over the kind of the structure of the degrees, but what do we actually do when we do the teaching? And earth sciences is kind of unique amongst subjects, is that we actually do quite a lot of our teaching in the world, in the outside, on field work and on field trips. So we go to all places in Scotland, not all of Scotland. We go to a whole bunch of places where we can observe some of these physical processes and evidence of physical processes in Scotland. So this is our volcano here in the middle of town. We go to that a few times to build up skills, but also to build up students' appreciation for the kind of the scientific history of Edinburgh and geology at Edinburgh. So we go to a whole bunch in Scotland. We also go to not Scotland. So we have the Lake District, which is not Scotland. We go to Jamaica, part of the environmental geoscience course. The fifth years go to Iceland to look at active surface processes and volcanism and glaciology. Also Cyprus, our geologists and physical geographers go off to Cyprus to look at that interaction between tectonics and sediments and climate. I guess I should also mention I guess we also have lectures and practicals and things like that. We've got an example of a lecture later on this afternoon at 2:50 in the Swan building. Come along to that, it'll be fun. There'll be an experiment, which might be messy. International exchange. So almost all of our degrees have the possibility to do a year abroad, usually as part of the third year. We have two systems for this happening. So you can enter the wider university pool of exchanges, which can be to anywhere in the world. But you have to convince us, the earth science staff, that the courses you'll do there will match the courses you'll do in Edinburgh. This is so that when you come back, you don't come to the fourth year and go, oh, I didn't learn anything when I was away, and now I'm failing. So students do that. So students do those away things, and we check, and it turns out fine. But we also have some specific exchanges where we've already done that checking of courses. So those are places, a couple of places in Sweden, places in New Zealand. We've just set up another one to Calgary, I think, in Canada. There's also to Queen's University in Canada, Salamanca in Spain, and Grenoble in France. Grenoble's in France. I'm not a geographer, so... so there are a whole bunch of places you can do these exchanges. But actually, because Edinburgh is such an international city, both as the university and the wider city, you also benefit from all these exchanges just by staying here. Because you have that cultural exchange with students coming in and visiting and joining our course and working with people from different cultures, maybe with different language skills, which is really important for building up your transferable skills and making you employable. If you just kind of work with a bunch of people you're comfortable working with, yeah, you've not become a useful person. Because when you go out and work in the real world, you'll be asked to work with people that can have poor language skills or have a different approach to looking at problems. Okay, so having that brought to you is kind of like having an exchange, but being in Edinburgh. But it's not quite an exchange because going away is more fun. So our learning and assessment methods, I guess this will be the same at every university you go to. We don't just have lectures, you write stuff down, we never see each other, and then I write an exam and, oh, I'm so disappointed. That doesn't happen, right? I'm quite often disappointed, but that's not the reason why. We do a whole variety of different kind of assessments, we have labs, which are kind of problem sets, we have labs which are kind of like chemistry labs, we have report writing, we don't just assess on exams, we have all kinds of different project work which you will do throughout your degree, and that's not just to kind of, so we can mix it up, it's actually because it's useful in helping you learn. I'm probably running way behind. No, okay, fine. We do group work, and students hate group work. It's like, oh, it's so unfair, this guy didn't do it. But it's really important. Okay, we do it not because you hate it, we do it because it's good for you. We also are fortunate enough to have in Edinburgh the Institute of Academic Development, which is this organisation which is useful for students, so they will help run sessions on how to write a better essay, how to make notes better, how to become a more effective learner. And that's a really great resource for students. We make quite a lot of use of that through our group tutorial system. So as well as lectures, you'll have tutorials with groups of students, and we kind of often do study skills as part of that. But also, it's really important because our staff learn quite a lot from this. So we have continual professional development of our teaching staff so that we're constantly thinking about how we can improve our teaching delivery and things like that. So turning on to the support that our students get, so we do have this, I forgot, Institute for Academic Development note out there. So they are part of the academic support that we provide our students outside of like regular lectures and practicals and fieldwork. And that's usually through the personal tutor system. So when you arrive, you will be assigned a personal tutor that will usually be with you throughout your whole time at university, just to make sure that you're academically progressing. We have a whole bunch of other student support for other student needs. So if you're having kind of emotional crises and things like that, we have a student support coordinator who can point you in the right direction, can actually help with emotional crises. So personal tutors are quite often scientists, so a little bit emotionally damaged. So there's a whole separate stream of help that's available to you, and that can be within the school or at the university level through a whole bunch of other things, including the Students' Union. And the Students' Union in Edinburgh are really fantastic. They're a massive resource to other students. I mean, the Edinburgh University Student Union is such a great organisation. They provide such fantastic feedback on our teaching, in terms of not saying, oh, you're great, you guys are amazing. They're really constructive. Things like this recording system, it wouldn't exist if it wasn't for our students going, hey, can we have a recording system? And these are all the reasons why it'd be useful, not just so we don't have to turn up to lectures. So there's all that kind of stuff. We've got a whole bunch of technical support as well. If you do come to university, maybe at Edinburgh or anywhere else, don't buy any Microsoft software or any kind of word processing stuff like that, because you'll get it for free. Huge amount of electronic resources in terms of online storage and keeping your stuff safe. And then the little box over here, GeoPals. Most schools have this now, but it's basically students from the second, third, and fourth year helping out students in the first, second year. And it's got really nothing to do with academic staff at all. We don't help run it at all. It's very much a students for students. So if there's something help you need with, you can see your personal tutor, but you can also kind of get help from other students. And it's a really effective way of learning. I'm out of time. Our students are quite employable. We actually have our graduates come and talk to us and say, what do you want? We say, what do you want? And they tell us. In terms of what kind of things we should be teaching our students. So it makes sure that our courses stay relevant and keeps our students employable. And there's all kinds of things you might traditionally think a geologist might do, but it's a physical science degree. Okay, you can do anything. The career service, they're very good. It's not just, an arm's length body. We have someone that's there just for earth sciences or just for geosciences. And we also bring in graduates to come to give us careers talks about what they're doing in their job, how did they get there. Our students find that very, very useful. Just to finish, or just almost finish, I thought I'd just mention this. So our offers and admissions requirements are kind of online. You can kind of see them. This is just a summary. It's not the entire story. There are different things for direct entry, that kind of thing. Just to point out that if you get an offer and you miss that offer, It's not the end of the world. There